Okay, so today we're going to be looking at the shadow problem with regards to related rates, and they tell me that a street light is mounted at the top of a 6-meter pole. So here's my 6-meter pole and here's my street light, and the street light is forming a diagonal beam which is going towards the horizontal line, as you can see. And they also say that a man who is 2 meters tall, so here's the man in question, and as you can see, this is approximately 2 meters, and they tell me he walks away from this pole with a speed of 1.5 meters every second, and they say that's along a straight path. So if I think about the distance between the man and the pole and I want to denote it by x, well, I can say that the distance that x is changing with respect to time, so remember that x is the distance between the man and the pole, and I'm saying that's changing with respect to time at 1.5 meters every second. And I can change that into a fraction. It's going to be 3.2 meters every second. Okay. So they want to know how fast is the tip of his shadow moving when he's 10 meters away from the pole. Okay, that's kind of an odd question. So let's assume that right now he is 10 meters away from this pole, because this 10 meters is not really going to help us in our solution. Okay, so I know he's 10 meters away from this pole. So notice that when he's walking along this straight path, that his shadow is going to be casting along this line, which is my hypotenuse on my smaller triangle. As you can see, I have it in red. Okay, so once again, here's my light, here's my beam of light, and as this man walks across this path, this is his shadow that's casting on the ground. Okay, so if the hypotenuse is the shadow, they want to know how fast the tip of the shadow is moving when he's 10 meters away from the pole. Okay, and like I said, this 10 meters is not really going to be used in our solution. So what do we really want? Well, we know that as this man walks away from this pole, that's going to be denoted as dx dt, because that's the speed that he walks away from the pole. So what is dy dt? Well, dy dt is going to be the length of the shadow and how fast that's changing. But that's not really what we want in this question. That's a different question. We want the tip of the shadow. So we can say, well, the tip of the shadow is the same thing as saying x plus y. Okay? And if I want to know how fast the tip of the shadow is moving, well, I'm going to take the derivative of this with respect to time. Okay? So this is what we want. So once again, dx dt is how fast he's walking away from the pole. Dy dt is going to tell me how fast this length of the shadow is changing. Okay? And what we want is dx plus y dt, because that's going to tell me how fast the tip of the shadow is moving as this man walks at that constant speed. Okay, so let's get into the solution. So I want to relate x, y 6 meters and 2 meters. And you can notice that I already have two triangles, and these are going to be similar triangles because I have one right angle triangle and I have another right angle triangle which has the same angle theta, and also this is inscribed within this bigger triangle. So I can say, okay, by similar triangles, well, I'm gonna take, okay, before I go to that, let's look at the angle theta. Okay, so if I look at my angle theta, I want to take the opposite of the big triangle, so that's going to be 6. Okay, and I want to take the opposite of the smaller triangle, and I want to put it on the other side. Okay, and I want to have the adjacent of the bigger triangle, so that's going to be x plus y, and I want to have the adjacent of the smaller triangle. Okay, so let me go over that one more time. So if I look at my angle theta, I want to have the opposite of the bigger triangle divided by the adjacent of the bigger triangle, and I said that's equal to the opposite of the small triangle divided by the adjacent of the small triangle. Okay, so that's by similar triangles. So by simplifying this, I get that 6y is equal to 2x plus 2y, and that's by cross multiplying. So what I'm gonna do is solve for y, because if I can solve for y, then I can substitute it in what we want. Remember, we want this, and I can take the derivative of x with respect to time. Okay, so let's solve this for y. So if I take this across, it's going to be 6y minus 2y equals 2x, and that's going to be 4y equals 2x, and that's going to be y is equal to 2x all over 4, or x over 2. Okay, so let's get back into what we want. So we want dx plus y by dt. Okay, so what is that equal to? Now that's going to be equal to x plus, we said y is the same thing as x over 2, so we can say this is x over 2. This is going to be the same thing as 3x over 2. And now if we take the derivative of this with respect to time, this is going to be 3 over 2 multiplied by dx by dt, because we are taking the derivative with respect to time. Okay, and remember that we have dx by dt. We said that it's 3 over 2 meters every second, so this is going to be 3 over 2 multiplied by 3 over 2, and that's going to be 9 over 4 meters every second. So once again, how fast is the tip of his shadow moving when he is 10 meters from the pole? Well, like I said, we're not going to be using the 10 meters. Well, it's moving at 9 over 4 meters every second.